Unscrew one bulb, and every other light stays on. That is the whole point of parallel wiring, and it is how every light in your house is really connected. This is how to wire lights in parallel. On screen is the finished diagram. Several lights, all lit, all sharing one supply. Watch what happens. Take one light out, and the rest do not even flicker. Do that on a series circuit, and everything goes dark. Stay with me. Why house lights are parallel, how the joins actually work, one switch running several lights, and then we build it live in the browser. So start with the big idea. There are two ways to connect lights, and only one belongs on your mains. Series is a single loop. The current runs through the first light, then the next, all in one line. The supply voltage splits between them, so each light gets only a share, and they all glow dim. Worse, break the loop anywhere, and every light goes out. Old cheap Christmas strings work like this. Parallel is different. Every light sits on its own little branch, straight across the supply. So every light gets the full voltage, full brightness. And because each one has its own path, one failing does not break the others. That is why your home is wired in parallel. Full brightness on each fixture, and one dead bulb never takes the room down with it. Quick pause. The exact parallel lights diagram in this video is free to open in your browser at CircuitDiagramMaker.app. No install, no sign up. The link is in the description. Open it and follow along. Right, how the wiring actually joins up. Here is what parallel really means in the cable. Think of two rails running along the ceiling. One rail is the live, the switch live once it is past the switch. The other rail is the neutral. Every light fixture simply bridges the two. Its live terminal taps the live rail. Its neutral terminal taps the neutral rail. So all the lives are joined together, all the neutrals are joined together, and each fixture hangs across them like a rung on a ladder. That is the entire trick. Because every fixture connects straight across the same two rails, every fixture sees the same full voltage. 230 volts in the UK, 120 in North America. The same at the first light and the last. And the earth. Every metal fixture also gets a protective earth, joined all the way through. So a fault trips the breaker, instead of making the light live to touch. Earth carries no current in normal use. It is there for the day something goes wrong. Now, the part people actually want. One switch, several lights. You do not need a switch per light. The switch just controls the live rail. Put one single switch on the live, feeding those two rails, and it turns all the lights on that circuit on and off together. That is how a single switch runs a whole room, or a whole hallway, of downlights. Adding another light later is just as easy. You are not rewiring anything. You simply add one more branch across the same two rails. Tap the live, tap the neutral, run the earth through. One more rung on a ladder. That is the quiet superpower of parallel. Each extra light is independent. Full voltage, its own path, and nothing about the existing lights has to change. In real houses, this is usually done with a loop-in method. Instead of a separate junction box, the joins live inside each ceiling rows or fitting. The cable loops from rows to rows. At each one, the lives connect through, the neutrals connect through, and a switch drop carries the live down to the wall switch and back. It looks busier than our clean diagram, but electrically, it is the same parallel rails. And one safety line, because this is mains. This video explains the circuit and the diagram. For real installations, isolate the circuit, follow your local electrical code, and use a qualified electrician. Now, let us build it live in a browser. This is the free editor at CircuitDiagramMaker.app. Watch two lights go in parallel off one breaker and one switch. Search the library, a breaker, a switch, two light fixtures, a ground. Click to place each one. Then press W for the wire tool and click pin to pin. Breaker to switch, that is the live feed. Switch out to the first light and switch out to the second light. Both lights tap the same switch live. That is the parallel join. Now the neutrals. Each light's return goes back to the shared ground. Two lights, one switch, both fed straight across the supply. The wires route themselves at clean right angles. And here's the part one love. It actually simulates. Hit Simulate, choose DC operating point, and run it. The built-in engine solves the whole circuit and drops real numbers straight onto the diagram. Voltage on every node, current down every branch. You can watch each light sitting at the full supply voltage on its own path. Break one branch, and only that branch falls to 0. The rest keep their numbers. Proof on the diagram that parallel is doing its job. So here's the whole thing, one more time. House lights are wired in parallel, not series. All the lives join, all the neutrals join, and each fixture bridges the two. So every light gets the full voltage on its own branch. One dead bulb never kills the rest. One switch can run the lot, and adding a light is just one more branch across the same rails. Want it to stick? Open the same parallel lights circuit free in your browser, run the simulation, and pull one light out to watch the others hold. The link is in the description. No install, no credit card. New to wiring? Watch the light switch and LED videos next. And subscribe for a new wiring diagram, explained every week. See you in the next one.